Welcome to Ford PowerForce Tech Talk. In this series, we'll focus on tips to help you fix Ford and Lincoln vehicles right the first time. Variable Camshaft Timing, or VCT, controls the engine's camshafts. VCT systems offer important benefits: fuel economy and lowered emissions, as well as improved performance and idle quality. The VCT system inputs signal information to the Powertrain Control Module, or PCM, through the camshaft position sensor and crankshaft position sensor. This closed-loop communication helps improve performance in various driving conditions. It also helps with diagnostics of the VCT system. Diagnosing a modular VCT system can be a challenge because multiple systems or components can cause the same symptoms. For example, an electrical circuit diagnostic trouble code, or DTC, can be caused by a sensor or circuit issue. It can also be caused by hydraulic or component issues affecting the VCT system, making a circuit-related DTC difficult to diagnose. Some of the concerns that customers bring up, such as the check engine light is on, running rough at idle, and misfiring, are often mistaken for other systems or components. But they could be caused by the VCT system, especially when no specific VCT DTCs are present in the PCM. After verifying the concern, although it may be intermittent, the first step in diagnosing a potential VCT issue is to check engine oil level and condition. Engine oil in good condition is necessary for proper VCT performance, and contaminated oil might be the cause of the concern. If you perform an oil and filter change to address a VCT-related issue, save the oil and filter in an approved container. The condition of the oil and material found inside the oil filter may be needed later to help assess other potential issues that affect the VCT system. If lack of maintenance isn't the problem, check the maintenance history, especially the warranty and repair history, for signs of recurring drivability issues. Then, it's time to perform some preliminary diagnostic steps to see if any VCT issues might be causing the customer's concern. Modular variable cam timing, or VCT issues, can be hard to diagnose. Their symptoms often look like something else. Before you start performing a repair on what might be a VCT issue, you need to perform some preliminary diagnostics. In fact, these are good steps to take whenever you have concerns involving misfire, idle quality, or engine noise. First, check for diagnostic trouble codes, or DTCs, in the Powertrain Control Module, or PCM. You also might find that cylinder misfire DTCs are present, but even if there's no VCT trouble code, this could still be a VCT-related issue. If there are misfire DTCs in combination with VCT-related trouble codes, verify that the VCT system is not what's causing the misfire. Also, if there is engine noise present, try to isolate the VCT system first. Turn the engine off, and electrically disconnect the VCT solenoids. Then take the vehicle on a road test. If the engine noise is gone or changes, it suggests a VCT issue. This diagnostic step can be effective because disconnection of the VCT solenoid will lock the VCT phasers in place. It eliminates a lot of other systems that can cause the same symptoms, including the fuel delivery, ignition, and some base engine concerns. If the symptom is intermittent or there are no DTCs in the PCM, but the drivability symptom is present, then you want to use the Integrated Diagnostic System, or IDS. Check the VCT Advanced Error Parameter Identification, or PID, on both the left and the right banks. While in closed-loop operation, VCT Advanced Error PIDs should hover around 0 degrees. A difference of no greater than plus or minus 5 degrees for an excessive amount of time is allowable. Also, it can be helpful to monitor the activity of the percentage of solenoid duty cycle PIDs. Pulse width modulation should be the same for both banks. If there is significant disparity with the response on one bank, the PCM will try to make an adjustment for the affected bank by increasing the duty cycle. You can see that here while monitoring these PIDs using the IDS data logger. Note that some minor variation is considered normal. Use the Integrated Diagnostic System or IDS scan tool to monitor PIDs at idle. Make certain the VCT system shows closed. If the VCT system is in open loop, the system will be disabled and the PIDs will not be relevant for diagnostic purposes. Another technique is to drive the vehicle and attempt to verify the complaint. Get a second technician to watch the IDS screen while driving to see if the VCT system stays in closed loop, and to watch how the VCT PIDs are reacting when a drivability condition is present. You can make an IDS recording of active PIDs if a second technician isn't available. If the drivability concern is verified and VCT PIDs show excessive variation while the concern is present, this suggests the symptoms are related to the VCT system. When diagnosing VCT issues, it helps to take a systematic approach by exploring 4 main areas of investigation: oil pressure, excessive oil bleed-off, a restriction in the oil passages, and mechanical failure. The modular engine needs proper oil pressure to maintain control of the variable cam timing or VCT system. When the VCT loses control, even though the engine oil is at the proper level and in good condition, start by checking the oil pressure. Make sure the engine is at normal operating temperature when you perform the test. Since temperature will impact the viscosity of the oil, the accuracy of an oil pressure reading can also be affected. Use a mechanical gauge at the oil filter adapter pressure switch. Instrument panel readings are not acceptable for this task. Start the vehicle. Don't touch the accelerator pedal. That keeps the VCT system inactive. Look for a minimum oil pressure of 15 psi at idle. At this point, the VCT should not yet be engaged. If oil pressure is okay and you notice VCT activity while monitoring parameter identification or PIDs at idle, this suggests the concern is not oil pressure related. If oil pressure is okay at idle, drive the vehicle and allow the VCT system to enter closed loop and operate. Then, decelerate the vehicle back to idle. If the oil pressure reading is too low, the camshaft may oscillate and cause drivability symptoms, which may include engine noise. Make sure to check the oil pressure right when the drivability symptom is present, using a mechanical gauge. Next, let's continue our systematic approach to diagnosis by looking for excessive oil bleed-off. When there's excessive oil bleed-off in a modular engine, sufficient oil may not reach all of the components that need it. The variable cam timing or VCT system requires oil pressure and volume to operate properly, so excessive bleed-off can be a problem. If you suspect the VCT system is the issue, make sure there are no concerns with engine oil level, condition, or low oil pressure affecting VCT performance. Then, check for excessive oil bleed-off in the engine. Install a mechanical oil pressure gauge at the oil pressure sensor. Start the vehicle, but do not step on the accelerator. Monitor the oil pressure while the engine oil is cold and during the engine warm-up cycle. Look for fluctuating oil pressure when the engine becomes hot. That suggests an excessive oil bleed-off condition, such as a failed bearing. If you suspect a bearing failure, inspect the engine oil and the oil filter. Excessive metal contamination found in the oil filter pleats may indicate internal engine issues. But take note, if an oil and filter change was completed just before this step, it can lead to misdiagnosis. Another place to check for excessive oil bleed-off is the cylinder head cam bore. The camshaft and cam caps can also be inspected for excessive damage or metal transfer. Some light scoring is normal, but if the scoring has increased the diameter of the bore to where oil can run out freely, that can cause a problem with the VCT system. One area that many techs mistakenly think there might be excessive bleed-off is the chain tensioner. The seal on the chain tensioner is only a dam to prevent noise on cold starts. So if you see a torn seal here and you think only replacing the chain tensioner will fix the VCT issue, it's a myth. Next, let's take a look at possible areas of restriction that could be the cause of VCT issues. When checking a modular 3-valve engine for a restriction in the lubrication system, first do an inspection for sludge. You may have already inspected for a general lack of maintenance, but also verify that no sludge exists in the engine. Sludge can lead to repeat repairs. The first place to look for clues is inside the oil filter. If you cut the oil filter apart, check for a deteriorating oil filter, which can be a sign of a lack of maintenance, as this could deposit filter media in the variable cam timing or VCT valve body assembly and solenoid. Also inspect for metallic debris. Remember, a little bit of metal distribution is normal. One speck of metal doesn't mean an internal engine failure. However, a significant amount of metal in the filter could signify an internal engine issue. If you check the filter and find colored flecks similar to these, and you're working on a Ford remanufactured engine, there's no cause for concern. That's just the paint used during the assembly process. It will not affect engine operation or durability. This shouldn't be mistaken for bearing failure, so carefully inspect for colored flakes versus metallic flakes. Also, check the cylinder head and VCT valve body for sludge, metallic debris, or filter media. The VCT valve body assembly is fed oil from the number 1 cam bore. You can check inside the valve body assembly, the VCT solenoid, and oil passages within the cylinder head to verify either metal, sludge, or filter media are in the system. Debris or sludge in any of these locations can cause the restriction of oil flow. If further inspection is required, especially if previous repairs have been performed, such as cylinder head replacement, it may be necessary to remove the oil pan and inspect the cylinder block too for excessive sludge or debris. Next, let's look at the kinds of mechanical issues that can play a role in VCT concerns. When diagnosing a possible modular variable cam timing or VCT concern, mechanical failure can be a factor, so you need to check a couple of areas thoroughly. First, take a close look at the solenoid. When testing, make certain there are no physical or electrical issues affecting VCT solenoid functionality. Physical issues can be caused by lack of maintenance, and they can affect internal solenoid capability. A simple test to check VCT solenoid function is to provide fused power directly to the VCT solenoid. Then provide a temporary ground. Listen for an audible click from the solenoid as ground is applied. Also, monitor engine performance. If the solenoid actuates, idle quality will change. Only electrical solenoid concerns or circuit-related issues can set the diagnostic trouble code or DTC P0010 or P0020 in the powertrain control module or PCM. Check to make sure there are no power or ground-related issues, and check the electrical connections at the solenoid and potentially at the PCM. Another important area to check for signs of mechanical failure is the VCT phaser itself. If the phaser is internally compromised, it can cause issues with cold start drivability, idle quality, engine noise, and while driving. Don't forget to check for signs of a lack of maintenance, such as sludge or metallic debris that could impact the VCT phaser's performance under a variety of driving conditions. You may need to visually inspect the VCT phaser indicator fingers on the left and right heads. There are 5 indicator fingers on the VCT phaser. The odd finger should be directly over the letter L on the VCT sprocket while in its normal resting state. If the indicator finger is rotated too far clockwise from the letter L, damage during installation or reinstallation could have occurred during the torque to yield sequence. See our Tech Talk video on VCT phaser installation for more details. If the VCT indicator finger is too far counterclockwise, sludge or debris could be inside the VCT phaser, causing an under-rotation. Look carefully for any electrical DTCs, such as P0340 and P0345. These electrical circuit DTCs can be set by other issues within the VCT system, such as low oil pressure, oil bleed-off, restrictions in the lubrication circuit, and damaged VCT components. In these instances, the VCT system PID may show open loop, disabling the VCT system, making it difficult to diagnose the root cause. You may need an IDS oscilloscope to understand what the concerns are. If there are no issues with lack of maintenance, oil pressure, bleed-off, or restrictions affecting VCT system function, it may be necessary to take the vehicle to a local Ford or Lincoln dealer, or visit motorcraftservice.com to address these issues. Motorcraft's full line of high-quality motor oils is formulated for naturally aspirated, turbocharged, and supercharged gas engines, and also for diesel engines. Most Motorcraft oils come in convenient 1-quart bottles, or easy-to-use 55-gallon bulk quantities for busy shops. Using bulk oil is environmentally proactive, and it can provide a substantial savings. And when you're choosing parts for all of your repairs, remember that Motorcraft parts feature a 2-year, unlimited mileage warranty. That's all for this post. Thanks for watching, and check out the rest of our series of installation and repair tips for Ford and Lincoln vehicles. For more information on Ford or Motorcraft parts, contact your Ford or Lincoln dealer or distributor, or visit fordparts.com.